Hi guys, today we're going to talk about the Unit 6 review. So number 1 says determine if the following are arithmetic or geometric and then write both the explicit and recursive forms. So part A wants us to look at what moves us between 45, 60, and 75. Well, if you add 15 to each one, you get 45 plus 15 is 60, 60 plus 15 is 75. So this one, because we're adding the same thing each time, is arithmetic. Okay, so now we need to write the explicit and recursive forms. So start with the explicit, which is a sub n equals a sub 1 plus n minus 1 times d. So let's plug in what we know. So we know a sub 1 is our first term, which is 45, and our d value is 15. Because that's what you add each time to get to the next one. So then we're going to simplify. So we're going to distribute the 15. So 15n minus 15. So then a sub n equals 15n, and 45 minus 15, 45 minus 15 is 30. So plus 30. So our explicit formula is that. So now let's do our recursive. So recursive, you start with your first term, which was 45, and then you have a sub n equals a sub n minus 1 plus your common difference, which is 15. So that's our recursive form. Let me make this a little smaller. All right, number 2, or part B. To get from 100 to 50 and from 50 to 25, it looks like we're dividing by 2 each time. However, remember in geometric, because this is what this is, because we're multiplying by 1/2. So our R value is 1/2. So let's write our explicit. So a sub n equals a sub 1 times R raised to n minus 1. So a sub n equals our first term, which is 100, times our ratio, which is 1/2, raised to n minus 1. So that is our explicit form. Our recursive form, once again, we start with our first term, which is 100. Then we have a sub n equals our ratio of 1/2 times, or I'm going to write it like this. Put 1/2 in parentheses. It doesn't really matter. Times a sub n minus 1. And that's our recursive form. All right. Number 2, find the 20th term for the following sequences. So number 1 is arithmetic because it has a d value. So that's our common difference. So we have to find the 20th term. The easiest way to do that is to find the explicit formula. So a sub n equals a sub 1 plus n minus 1 times d. Simplify by distributing. Plus 2. So our explicit formula is negative 2n plus 37. Now we can use this to find our 20th term. So we're going to say a sub 20 equals negative 2 times 20 plus 37. And then we just plug that in. So negative 2 times 20 plus 37 is negative 3. So our 20th term for this formula is negative 3. All right, part B. 2 times 2 is 4. 4 times 2 is 8. So this one is geometric. So our R value is 2. So let's once again find our explicit form. So we're going to say a sub n equals our first term, which is 2, times our ratio, which is 2, n minus 1. And we know n is going to be 20 because we want our 20th term. So a sub 20, 2 times 2 raised to the 20 minus 1. Put that in our calculator. We get a sub 20 is 104,8576. So 1,048,576. Part 3, or number 3, says find the sum of the first 10 terms for the following. So if we look at part A, 8 times 2 is 16. 16 times 2 is 32. So R is 2. So we want the first 10 terms. Excuse me. So that means we're going to find the finite sum. So we're going to have our formula, which is this. And I know on Delta Math it looked a little bit different, but it's essentially the same thing. So this is our formula. So now let's plug in what we know. So we know our first term is 8. So let me see. Let me move it down a little bit further. So our first term is 8. Our ratio is 2. And we want to find the first 10 terms. So our n value is going to be 10, all over 1 minus 2. Now when you put this in your calculator, you need to make sure you put parentheses around everything that I just put parentheses around. And our answer is the 10th term, the sum of the first 10 terms is 8,184. Okay. Part B, we're going to do the same thing. So we're going to say sum of the first 10 terms equals our a sub 1 value, which is 500, 1 minus our r value, which is 1/2. We want to the 10th term, all over 1 minus 1/2. So when we plug that in our calculator, we get 500 times 1 minus 1/2 raised to the 10th divided by 1 minus 1/2, which is 999.023. All right, number 4, it says find the sum of the following if it exists. Okay, so these, if you notice, they don't have an ending value. So this means that these are infinite. So we're going to use the infinite formula, which is a sub 1 over 1 minus r for all of these. So part A, our a sub 1 value is 500. Our r value, well, if we divide 100 by 500, we get 1/5. Oh, be careful though, because it is a negative 100. So our r value is negative 1/5. So let's plug it into our formula. So we're going to say the sum is 500, so our a sub 1, over 1 minus our ratio, which technically is 1 plus 1/5. So when we plug that in, we get 500 divided by 1 minus negative 1/5. And our answer is 416.67. Now this worked because our r value was not bigger than 1. So it worked because our r value was a fraction. Part B wants us to do the same thing. So our a sub 1 value is 8. Our r value, we're going to do 24 divided by 8, which gives us 3. So our r value is 3. But now, let's think about this logically. If our r value is 3, that's bigger than 1. So this has no sum because the r value is greater than 1. And then part C, our a sub 1 value is 900. Our r value is 300 divided by 900, or 3/9, which reduces to 1/3. So our r value on this one is 1/3. So that works. That one means it will have a sum. So let's plug it in. So a sub 1 over 1 minus your r value, or your ratio. So this one is 900 divided by 1 minus 1/3, Our sum of this one is 1350. Okay. All right, number 5, we get into sigma notation. So find the sum for the following. Notice part A, it goes to infinity, and that means it's an infinite geometric. So we're going to use the same thing we just did. So S equals A sub 1 over 1 minus R. Our A sub 1 value of this one is 8, and our R value is 4/5. So this one does have a sum. Our R value is less than 1, so it works. So our sum equals 8 over 1 minus 4/5. So when we plug that in our calculator, 8 divided by 1 minus 4/5, we get 40. So our sum for number 5A is 40. Part B, this one is only going to 20, so this is finite. So that means we use the sum of the first 20 terms, because that's where it goes to, is A sub 1 times 1 minus R to the n over 1 minus R. So our A sub 1 value is -2, our R value is -1/2, and our n value, you're going to the 20th term. So our n value is 20. So let's plug in. So we get A sub 1 times 1 minus R raised to the 20th all over 1 minus R. So when we plug this in, we get -2 times 1 minus -1/2 raised to the 20th divided by 1 minus -1/2. And that gives us a sum of -1.33. So for part C, if you look, this is neither arithmetic or geometric. So what we're going to have to do is use our sigma notation to find out all 5 terms and then just add them together. So our first thing we start with is 1. So we're going to say 3 times 1 squared plus 4. Then we're going to go all the way up to 5. So 3 times 2 squared plus 4, 3 times 3 squared plus 4, 3 times 4 squared plus 4, and 3 times 5 squared plus 4. So once we find all of these, we can add them together and get the sum. So number 1, 3 times 1 squared plus 4 gives us 7. And then 3 times 2 squared plus 4 is 16. 3 times 3 squared plus 4 is 31. 3 times 4 squared plus 4 is 52. And 3 times 5 squared plus 4 is 79. So now I'm going to take 7, 16, 31, 52, and 79 and add them all together. So 7 plus 16 plus 31 plus 52 plus 79 gives us a sum of 185. So that's our answer for C. So part D, we're going to do the same thing we just did. So we're going to go from 1 to 3. So 8 times 1 minus 9 over 3. 8 times 2 minus 9 over 3. And 8 times 3 minus 9 over 3. So 8 times 1 minus 9 over 3 is -1/3. 8 times 2 minus 9 over 3 is 7/3. And 8 times 3 minus 9 over 3 is 5. So now we're going to add those together. So -1/3, 7/3, and 5. So -1/3 plus 7/3 plus 5, we get 7. So our sum for our part D is 7. Okay, guys, I hope that helped. Have a good day and good luck on your test tomorrow.